Alrighty guys, today we're going to be talking about an intermediate form of optimization, object pooling. Object pooling is pretty good. It's this methodology of reuse and recycle. That's why programmers are all vegetarians. It's because we love the environment. So, I'm actually going to be showing you how to do this, but I'm also going to prove to you why optimization might not be as important as you think it is. Not to say it isn't important, not to say you shouldn't be paying attention to it, but a good programmer can get away with keeping it until the end, and it's not that much of a worry. So, to start, we have a simple scene here, and if you just want to see the results of this, then you can go to the end, and I'll have a little section, I'll timestamp it on the screen. But we have a projectile with a sphere collider. Let's add a rigid body to it, and let's attach it to prefab it. We have an FPS display, which will just tell us what our FPS is and its average. I asked ChatGPT to make that, and we have a plane. And if you want to download this project, there will be a GitHub link in the description below with all three stages that we're going to do. Now, stage one, we're creating a game, and in this game, we're going to be spawning in thousands of projectiles. God knows why, but that's what we want to do. So I'm going to create an empty, and I'm going to call it spawner. And I'm not going to go over much of the code, only the code that's necessary. So I'm just going to create the spawner script, and this should hopefully be very familiar to you guys. Okay, so what I've done really quick is I've created a script that allows us to spawn an object with some force, and then it takes in a lifetime, so how long the object will be alive, how many of them to be spawned, and also how often they should be shot out. And our start function, we're just saying that they should immediately start, and then an update, we are updating our timer and having them shoot. If you're wondering why I didn't do a coroutine generates garbage. So that would actually not be great for our test. So we're just doing update for something like this. And we have our shoot function, and then we're going through every single one of our bullets, and we're shooting them. So I've gone ahead and I've set all the values. I'm going to put down the num to spawn to 50, and we're going to test it. You'll see that we get an absurd number of projectiles. There's a lot happening. And on average, our FPS is between 25 and 30. Okay, this is going to be benchmark 1. Let's go to Window, and then Analysis, Profiler, and we can see what's happening in here. So let's change it to Hierarchy, and let's put on Call Stacks and Deprofile. Okay, so now we can see everything. And let's just stop at one of these peaks. Okay, and as you can see, the player loop is taking up the majority of our time, which is alright. And camera render is over here. Let's turn off all the things that we have no control over. Rendering, at least in this case. Rendering, physics, animation, VSync, global illumination, UI. So all of this is stuff that we have a say in. And you'll see that when you click on something, it'll warn you what is doing that. So fixed update is taking up 22 milliseconds. What else? If we sort by MS, yeah, it's mostly just fixed update, which is from our update bodies, because there is just such an insane number of them. If we sort by garbage allocation, you can see that 2% of our cost is garbage allocation from our spawn and destroy. And that's kind of the idea of the object pool, is we want to remove that garbage allocation, and this garbage allocation is every single frame that we have this, which is not ideal. And if you were to increase this number even more, that would just only go up. So we can remove the garbage allocation pretty easily just by reusing our objects, and that's the idea behind a pool. So if I open Paint quickly, and if you've done any coding in the past, you should be aware that this exists. We have something called a queue. And queues are generally fantastic for a managed pool, which is what we're going to be making together. There's also an unmanaged pool, and generally you use an array for an unmanaged pool. But with our queue, the idea is you can only ever see the front and add to the back. So what we're going to do is if we take the one from the front and then push it immediately right back onto the back, well, then we get an infinite loop. And instead of deleting things, we're just always recycling. Because recycling is love, recycling is life. We love nature. So what I'm going to do is I'm going to create a new script, and let's call it pool. And then I'm just going to configure it. But before we do, because you are watching one of my tutorials, I'm going to give you the full shebang. Whoa! We're going to create a serializable private struct, and we're going to call it pooled object. And our pooled object is going to have a public rigid body prefab and a public int num to spawn. Now check this out. You probably did not know this exists if you're watching one of my videos. We can say serialized field here, private pooled object array, and then pools. Watch this. We can now go back in, create an empty, and give it our script. Create an empty, give it our script, move it around, and then look at that. You can just add a new element for each thing you want to do. That's all you need to do to add a pool. That's awesome. So let's add our projectile, and we're going to say that we need some absurd number. Let's do 10,000, just for safety. And let's open our pool now, and let's get to writing this. So what we're going to want to do is we need this might be a little strange, private static read-only dictionary of strings that all house a queue of, and then rigid bodies. Let's call it pooled objects. Long, I know. Then we need our awake function, because it needs to happen soon. And then we also need a public static void shoot function. And now what we're going to do in awake, first of all, is let's clear our dictionary. Okay, and then we're going to say, and the reason we need to clear it, sorry, is because it's static. And we don't want it to accidentally stack across scenes. So for every scene, we need to clear the dictionary again. Then we're going to say for each, and then in our pools, so for each pooled object pool, in pools, let's create a new game object. So, and this is going to be our transform parent. So transform parent is equal to a new game object, and let's call it pool.name. But before we do that, let's store the name, string name equals pool dot, and then prefab dot name. Put that over here, and then dot transform. Then we're going to say parent dot set parents, and it's going to be ourselves. And then we are going to access our for loop again, for into I is equal to 0. I is less than the number of elements in our pool, so pool.num to spawn, increase I by 1, and we're spawning every single element for each pool, and we're adding it to our queue, so let's actually create a queue here as well, a queue of rigid bodies. Let's call it objects to spawn. Okay, and then what we're going to do is we can say over here how many it should start with capacity-wise, so it doesn't have to allocate more memory dynamically. And then what we're going to do is for each, let's spawn an object, so instantiate, and our pool.prefab. That's it, and the parent is going to be our parents. Let's store its output. Then we're going to say objects to spawn dot on queue, and then RB. But before we do that, let's turn it off. Game object set active false. And then finally, at the end, let's add to our dictionary. So it's going to be pooled objects, add, and it's going to be our name alongside our objects to spawn. That's it. So what we're doing is we're creating a dictionary queue for every single object that we have requested in this array, which can be a lot of objects. But this is going to pre-do everything for us, and it's going to keep it nice and organized. Next, we need a way to actually access and spawn these objects. So the reason we made this static, and the reason we made this static, is so that way now I can go to the spawner class, and I can create a function in here. and I can literally say pool dot shoot, which is fantastic. Now the question is, what is the pool shooting? So we need a string name, we need a vector3 location, and we need a vector3 rotation, or not vector3, quaternion rotation. Then what we're going to do is, first of all, let's check to see if our pool actually contains this. So if our pooled objects dot contains key, name, and if it does not contain the key, then we should throw an error. So we'll do this. Debug dot log assertion does not contain key. Pool does not contain key name, and then let's return null. And I forgot to do this. We need to return a rigid body over here so we actually can access, just like the regular instantiate function, we can access what we're doing. Over here, what we should do now is we should access our object. So first of all, rigid body RB is equal to check our pooled objects at the index of name and then .dequeue. And then at the end, we're going to say pooled objects at the index of name dot and then requeue RB again. Then we're going to return our RB. And before we continue, we're going to say RB transform position, or transform not just position and rotation individually, because that is expensive. Instead, we're going to do set position and rotation. And we're going to say location, rotation. Okay? And finally, we need to do one more thing. We need to actually activate our object. So we're going to say game object, and then .set active true. Now there's an issue with this. Because we are moving our objects around, there's actually two issues with this. Because we're just moving our objects around, and we're not destroying them, there's two downsides. First of all, we can no longer destroy them like this. So that goes down the drain. How are we going to get rid of them after 4 seconds? And secondly, their force, because they're rigid bodies, isn't going to be modified back down to 0 when they're spawned in. It's going to be maintained, and it's going to look really bad. So what we need to do is we need to actually create a new type for this. So I'm going to create a projectile object, and we're going to attach the projectile script to the projectile itself. I'm actually going to make a duplicate and call it pooled projectile. Okay, and then in the spawner, I'm going to say our pooled projectile instead. Or I'm actually going to duplicate this as well and call this pooled spawner. Yeah, and then what we're going to do, let's go at the top and let's add a boolean. Okay, fantastic. This one is pooled, the other one isn't. And then finally in here, we need to change this to be our pooled projectile. Now there's an issue. In our actual projectile script as well, we need to make sure that this is handling all of our object's operations. Let's go to our pool and let's modify this. Instead of rigid body, we're going to spawn projectiles. There we go, no issues. Back to spawner. In our pooled object shoot, and then let's do one more thing. In our projectile, we need to wait for it to destroy itself, right? So let's create update. So if we are less lifetime than 0, then we should turn ourselves off, return ourselves to the queue, and we are good to go. Now, in theory, this is going to work exactly the same as if we were to spawn 10,000 objects. But my point being that optimization is not as important as it seems sometimes, especially in small-scale cases like this. Even though there's a bunch of objects, there's often nothing you can do about it. Okay, so now let's disable the old spawner and enable the current spawner. So our pooled spawner, and let's give it a test. Wow, it's so fast because nothing is happening. Okay, so I made an oopsie. Let's go back to a script, and we need to change this to be a projectile as well, to a rigid body, and then because of that, we need to change this too. So we're not spawning a rigid body anymore, we're spawning a projectile. Unfortunately, this is going to tamper with our old test. So you know what, let's not do that. Instead, let's create another rigid body, and this one's going to be pooled projectile. just like this. And then this one's going to be a projectile. Let's use that one instead over here. That's better. Also on the projectile itself, make sure the projectile has access to a rigid body. Made another silly oopsie. Forgot the for loop over here. Okay, so now we're testing our pooled spawner, and you'll see that there is not much of a difference between the pooled spawner and the other spawner. It's maybe saving 2 or 3 FPS on a good day. And unfortunately, that's just all that is. The main cost is going into our physics system and rendering all the spheres, not the actual calculation of the spheres themselves. So, if we take a look at our process over here, you'll notice that if we turn on rendering, right, it goes up quite a bit, and especially if you turn on physics, it takes up a big chunk. Now, garbage collection is still taking up a big chunk, so let's go in and let's see what we can do. Our pooled shoot function is allocating quite a bit of garbage because of the get name function. Now, I intentionally left this in here just to show you how something so simple, .name, can cost so much. This cost us more than instantiate. This one little line. All we need to do to fix it is just store it before we use it. So a private string name, and then we store it. Name isn't the greatest name for it, but paste this here. Just that. And now let's try again. Okay, and you can see that we do have a bit of an improvement, but it is still incredibly minor. You can see that our garbage allocation has gone down, and it's just our GUI repaint that is taking up garbage. Okay, I don't think there's anything we can really do about that. If we press on stuff, you'll see that some of them will turn on, and it'll indicate to us what is in concern here. So our physics update, we can't do anything about that. Our mono behavior is taking up 6 milliseconds. So we can probably improve that. You can see that our 6 seconds are divided into chunks here. We have our update here, projectile update, which has 6,000 calls. And if you go down further, you can see that time.delta time is taking 0.51 milliseconds, and then turning the object on and off is also taking a while. So what we can do is something called batching. We have a bunch of objects that are all being used in the exact same way, right? And this is a very similar concept to what you'd see in something like ECS. And if you really want to optimize your game, like seriously optimize it, look into ECS. That is real optimization. That is going from 10,000 projectiles to 40,000 projectiles optimization. So what we're going to do, we're going to head over to our projectile script. And instead of doing update in here, we're actually going to do this in our pool. We're going to have an update function. And then we're going to have a private, not private, but a public static read-only list of projectiles. That's called updating projectiles. Then what we need to do is when we awake, let's clear it, just like we did with our pooled objects. And an update, let's create a for reverse loop. And we need to iterate through them in reverse. And then we need to store it. So we're going to say projectile p is equal to. Let's actually not store them as projectiles, but instead as game objects, because that's going to be, actually no, they do need to be projectiles. And then we're going to say, yeah, at the index of I, just like this. So we're getting our object. What we need to do then is we need to store our time. So float dt equals time.delta time. And this way we're only doing it once. And then we're going to say if, well, first p lifetime minus equals dt. If p lifetime is less than 0, then we need to do two things now. First of all, we're going to remove ourselves from the queue, or the list. So updating projectiles.remove at I. And secondly, we need to tell the object to destroy itself. So game object set active false. Okay? And now that we're doing the system as well, when an object is spawned in, they need to bind themselves to the queue. And you can choose where you want to do this. I'm going to do it in the projectile itself over here when we bind our object. I'm going to say if the lifetime is greater than 0, meaning it does have a lifetime in the first place, pool dot updating projectiles add this. And now we can delete the update function entirely. That's it. So this is a batched process, meaning that all of the bullets will be handled just here, and that's it. After a few seconds, once again, you can see that there's like a negligible change. Barely anything comes back to us, but it is starting to go up. It is most certainly starting to get better. If we sort by MS again, and we kind of just browse along, we can see that our fixed update loop is taking up a lot of it. There is literally nothing that we can do about this as far as I'm aware. It's just a physics system. And then it's now the camera, the rendering, is taking more time than our update, and that's how you know that we're on the right track. Next is pool.update. In pool.update, we have get item, which I don't think there's any way we can really improve our get item, and remove at, which is taking up its toll, which is fine. Get item could be improved if we did a for each loop instead of a for loop, but we need the for reverse, so that way we're able to delete the objects. So pool update is fine. There is the FPS display, which doesn't do anything. Our pooled shoot, which, look here, when you call pool.shoot uses 1.6 because, well, first of all, we turn the object on. Nothing we can do about that. But then also, because we have our dictionary dot, let's pull this over to the side, get item, because we're getting it. We're trying to find if the key exists, and then also if we contain the key in the first place. And just doing that is pretty expensive. So what we can do is back in our pool, and scroll down here, we can fix this. So instead of .contains key, we can say .try get value. Okay, and then we can say our name, and we're going to say out q of projectile p. And then over here, we can just say p.dq and p.onq. And that way we're only accessing the dictionary once. And that would save, well, if we're doing this 3 times, and this is taking up, 70 milliseconds, we are reducing it by 66%, so it's only going to take up 20 milliseconds. The downside to everything that we've done is we've put more pressure on our RAM, but generally, that is acceptable instead of putting pressure on the CPU. Finally, I don't think that there is any way we could optimize this further. And you can see now that we are at a consistent 30 FPS. Okay? There's another thing that you should keep in mind. If you are new to Unity, or you just have never tried this before, building your game has a substantial improvement on runtime. So what we're going to do now, just to finally test it, is I'm going to make 2 builds. One build showing our spawner, regular spawner, and the other build is going to show our pool system. So I'm going to turn both of these off and turn the spawner on, and then I'm going to build with Control B. And then at the top here, we can see that our FPS and our average FPS. This is the naive solution. We have an average of 35 FPS. Naive solution and turn on our solution. And there you go. You can see there have been performance benefits. Our FPS is almost, and get this, 10 more. It's 10 more frames per second. Woo! After all that work and understanding of C#, was it really worth it? Because this is an insane amount of projectiles to have in your game, right? So you almost have to ask yourself, are you doing this optimization because you need to, or because you've come down with a case of optimization paranoia? Look through your code, make sure that everything makes sense, and then plan your attack. If you would like me to look over something, I'm happy to, assuming I don't get flooded with these. I'm going to keep a link to my team's Discord, because we're also making a game, and I'd appreciate if you're a stranger on the web watching, if you join and help us make our game, just play test for us. I'd be more than happy to look through your code and give you advice where I can. That is it. I'll see you guys maybe in the next one, depending on how things goes. Take care, and that's it.